Next is seasonal variations in data. So far we looked at no seasonality, no trend, just random fluctuations. We used naive, moving average, weighted moving average, exponential smoothing for that case. We looked at trend projection using regression analysis. So now we're going to include seasonal variations in data as well. And we're going to use what is called a multiplicative seasonal model. There are lots of different ways in which seasonality can be handled, but we're going to take a very simple, straightforward approach, and we're going to use multiplicative model. So we're going to come up with a multiplicative factor for each season, and we will do the seasonal adjustment by multiplying the forecast before seasonality, okay, by the factor. Okay, when you multiply it by the factor, then you get seasonally adjusted forecast. So this is the approach we're going to use. We're going to find the historical average for each month. So that is, average is all seasonality stripped out. So that's a typical average. And then you compute the average demand for each of the months in a year. Okay, if it is monthly data, then you divide one into the other and you get the seasonal index. And then we can use that seasonal index to estimate the seasonal adjusted. So the next step is to estimate the total next year demand and then divide it into individual months and multiply by the seasonal index. So let's go through that now with a simple example. So we have monthly data. Okay. So each month we have 3 years worth of data, year 1, year 2, year 3. So find the average for each month. So January's average demand is 90, February's average demand is 80, and so on. This is average of these 3 numbers. Now you average these averages, then the monthly differences will get averaged away. Okay. You take that 1128 and divide by 12 months, you get 94. So 94 is the value that is stripped off all the seasonality. Okay, now you divide that 94 into 90, okay, and you get the seasonal index for January. Then divide 94 into 80, you get the seasonal index for February, and so on. So now you have the seasonal factor or seasonal index for each of the 12 months. Then you find total demand for this next year, year 4, say 1200. If that is the estimated forecasted demand for the entire year, you divide by 12 to convert that into monthly demand. That would be before adjusting for seasonality. And then you multiply by the seasonal index, and that will give you seasonally adjusted forecast. Now this 1200 may come from either moving average method or one of the exponential smoothing methods, or it could be trend adjusted forecast as well. Okay, let's look at a multiplicative model example. So this is the multiplicative approach. So we have 4 years worth of data divided into 4 quarters. So for spring, these are the sales figures from the last 4 years. So you add them, which gives you 16,000, and then you take that 16,000 and divide by how many years? There are 4 years, so divide by 4, you get the average for spring. So spring average is 4,000. Summer average, okay, again add them, you get 12,000. Then you go 12,000 divided by 4 is 3,000. Then this sum is 8,000. 8,000 divided by 4 is 2,000. And then winter is 1000. So these are the averages for each of the quarters. Now you average the average, then so you sum that, you get 10,000. The average of that is 2,500. Now you divide that 2,500 into each of these. So you get 4,000 divided by 2,500 is 1.6. 3,000 divided by 2,500 is 1.2. 2,000 divided by 2,500 is 0.8, and 1,000 divided by 2,500 is 0.4. So these are the seasonal factors or indexes.